Welcome to the deep dive. Today, we're embarking on a truly mind-bending journey. We're going deep into the very fabric of reality itself.
It's definitely going to stretch the mind a bit.
Absolutely. We're guided today by a really groundbreaking piece of work, something that promises to redefine how we understand the universe. We're deep diving into excerpts from Ontology of the Hyperfractal Manifold. It's by Randolph Lilien, just published in 2025.
And it's important to stress this isn't just, another vague theory.
Right. It's presented as a detailed conceptual and mathematical framework. The goal seems to be unifying the structural and functional sides of how the universe works through layers of dynamics.
Exactly. Structure and function deeply linked.
So our mission for this deep dive, we want to unpack this really dense material, pull out the most important nuggets of knowledge for you, give you a shortcut to getting informed about this revolutionary idea.
And there are some genuinely surprising facts buried in here.
I bet. Okay, let's jump right in then. What exactly is this hyperfractal manifold that Lilien is talking about? Sounds complex.
It is, but what's really fascinating here is that it's not just a static geometric concept like a map. Lillian's work defines it as a multi-layered dynamic structure. And it's embedded within higher dimensional space. It's governed by principles like resonance, coherence, and also these fractal scaling laws.
So multi-layered, dynamic, higher dimensions, resonance.
Think of it as both the underlying fabric of reality, the substrate, and also the generative engine that creates physical reality.
Substrate and engine. That's a powerful combination.
Mm-hmm. And the term manifold itself is key. It suggests many folds or layers.
Right, like folding paper.
Exactly. And that perfectly reflects its multi-layered nature. Structurally, Lilien says it consists of layers of something called asymmetry resonance operators. Functionally, it just operates across all these multiple levels. And mathematically, it gives you the flexibility to describe both really tiny local properties and huge global structures. It covers all the scales.
So you said it's not just a passive map. It's a dynamic, active engine constantly shaping reality. That feels like a really radical departure from, how we usually think about the universe's structure.
Precisely. That's the core idea. Lilien emphasizes its key features.
Right.
It's multi-layered, right? Each layer linked to one of these distinct asymmetry resonance operators.
Okay.
It does have a foundational geometric structure, grounded in something called hypersymmetric invariants. But it also incorporates these really dynamic processes: resonance, coherence, fractal scaling.
Fractal scaling, like snowflakes or coastlines.
Sort of, yeah, but applied to the universe's fundamental structure.
Right.
It exhibits self-similar fractal scaling. So recursive structures govern how energy and resonance are distributed throughout it.
Recursive, repeating patterns at different sizes.
Mm-hmm. And crucially, Lilien explicitly calls it an engine of emergence. It produces everything we actually observe: particles, forces, space-time through these layered dynamics.
Wow. An engine of emergence. That concept is really powerful. So how does this manifold actually build reality? Lillien's work paints this fascinating picture, proposing a four-tiered architecture.
Yeah, it's like the universe is constructed in layers.
Almost like levels in a building, starting from the basement principles up to the penthouse views we see. Can you walk us through this universal architecture? Where does the manifold fit in?
Okay, so if we connect this to the bigger picture, this ontology describes the fundamental layers of reality according to this specific framework. First, at the very bottom, we have the analectic layer. This is the foundation. It contains what the author calls ultimate invariants, the fundamental principles.
Like laws of nature.
Even deeper, maybe. Things like hypersymmetry, which is proposed as a deeper, more profound symmetry than we usually talk about, and hypergravity coherence. You can maybe think of that as the ultimate unifying force from which everything else springs.
Okay, ultimate invariance. Hypersymmetry, hypergravity, coherence.
Right. And the hyperfractal manifold's geometric foundation. It's rooted right here, defined by these unchanging conditions, often represented mathematically by a hypersymmetric metric tensor.
Got it. Layer 1, the absolute basics.
Then moving up, there's the holectic layer. This layer describes how fields emerge, like scalar fields, vector fields, tensor fields, the kinds physicists work with.
Okay, so fields come next.
Yeah, and these fields mediate or express the dynamics of those deeper invariants from the first layer. They essentially propagate on the manifold, extending those fundamental principles into dynamic relational contexts. And here, the hyperfractal's own layers, those asymmetry resonance operators we mentioned, they can be seen as sort of field-like in how they function.
So the fields carry the information from the base layer.
In a sense, yes. Then the third layer,
Yeah.
the relational mathematics layer. This is where a lot of the action happens, according to Lilien.
The action layer.
You could call it that. This layer describes the dynamics of resonance and coherence themselves and how they create relationships in the universe. It includes all the interactions, the transformations that govern the universe's relational structure. And Lilien explicitly states this is where the hyperfractal manifold primarily resides. It's dynamically creating and governing all these relationships through resonance, using its layered structure.
Ah, okay. So the manifold lives here in this relational layer doing the work.
Primarily, yes. That seems to be the core functional domain.
Yeah.
Finally, at the top layer, the derived mathematics layer.
Derived, meaning it comes from the others.
Exactly. This represents everything we can actually observe and measure.
Mm-hmm.
The manifestations of all the previous layers, things like the particles we detect in colliders, the forces we experience like gravity or electromagnetism, the measurable constants of nature.
So our everyday reality.
Pretty much. Now, the hyperfractal manifold isn't in this layer itself, but it provides the fundamental relational mechanisms down in layer 3 that lead to all these emergent phenomena we can see and measure up here in layer 4.
Okay, that clicks. The hyperfractal manifold is really the dynamic bridge. It's taking these ultimate fundamental invariants from the base layer, processing them through resonance and relationships in the middle layer, and that results in the observable universe we experience in the top layer.
That's a great way to put it, a dynamic bridge.
It's a truly elegant perspective, almost like a cosmic operating system running underneath everything. Now, here's where it gets, I think, particularly interesting, especially for anyone who's ever dipped into string theory.
Ah, yes, the comparison.
Lilien's work presents these dimensional layers of the hyperfractal manifold as, well, a revolutionary replacement for the abstract extra dimensions you find in string theory.
It's a bold claim.
It is. So what's the main critique of string theory's dimensions, according to Lilien? And how do these dimensional layers really differ?
Well, this really brings up a fundamental question about how we even conceive of dimensions, doesn't it?
It does.
The critique of string theory's extra dimensions, as laid out in Lilien's work, is basically that they're often presented as static, abstract, and typically compactified.
Compactified, meaning curled up really small.
Exactly. Curled up into tiny, unobservable spaces.
Yeah.
So the criticism is they can seem like a mathematical convenience, maybe a bit attached from observable physical reality,
Yeah.
often lacking an inherent dynamic role. They
Yeah.
just sort of sit there.
Like extra room dimensions that are locked and we can't access.
Kind of, yeah. In stark contrast, the hyperfractal manifold's dimensional layers are described very differently. They're presented as profoundly dynamic, functional, and deeply embedded within the universe's actual structure.
Not external add-ons.
Right. They're not external. They're continuously influencing the universe's evolution, and they're supposedly directly tied to observable phenomena. Each layer acts as one of those dynamic asymmetry resonance operators.
The operators again, like cosmic tuners.
That's a decent analogy. Like a tuner, or maybe a generator, actively shaping the universe's behavior. They do this by mediating transitions from those higher dimensional invariants down into our familiar emergent four-dimensional spacetime. They're also inherently relational. They are the mechanism for resonance and coherence, and they're fractal and recursive.
Recursive, meaning they connect the very small with the very large.
Precisely. Connecting small-scale quantum behavior with large-scale cosmological dynamics. It's all linked through these layers.
Okay, so these aren't just extra dimensions tacked on like, I don't know, mathematical ornaments. They're active components of reality actually driving what we see.
Exactly. That's the core distinction Lilien makes. He emphasizes their functional advantage.
Functional advantage.
Meaning they are integral to how the universe functions. They directly mediate emergence, coherence, resonance. This inherently ties them to the observable universe, unlike, arguably, the more abstract, compactified dimensions of string theory. They also offer this unified framework that spans both quantum and cosmological scales, obeying these fractal scaling laws. And they're claimed to produce directly observable effects,
Such as?
like the emergence of particles and forces, the coherence we see in quantum fields, even the fractal distribution of matter in the universe. The cosmic web structure.
The cosmic web, right? The large-scale structure.
And this focus on observable effects also directly tackles the issue of falsifiability, which is, a key strength for any scientific theory. Can we test it? Lilien argues we can test the effects of these layers.
That is a big difference. Falsifiability is crucial.
Okay, so this framework is clearly ambitious. It claims to explain the emergence of, well, everything we see. Particles, forces, even space-time itself. How exactly does the hyperfractal manifold achieve such a grand feat? What's the mechanism? It proposes a really revolutionary mechanism for emergence, built on those layers and operators. Let's break it down.
Yeah.
For the emergence of particles, Lilien suggests particles aren't fundamental points, but rather localized resonances, like specific vibrations or stable patterns emerging from symmetry breaking and coherence processes within the manifold.
Resonances,
Hmm.
like notes on a string.
That's a classic analogy, yeah.
Hmm.
And their familiar properties, mass, charge, spin, these, are derived from interactions between these dimensional layers and their relational dynamics. Those asymmetry resonance operators are key again.
How so?
Their specific outputs, mathematically, their eigenvalues, are proposed to correspond directly to particle properties. Mass, for instance, is linked explicitly to this hypergravity coherence. It's almost like how much a field interacts with a manifold's foundational structure.
Interesting. So mass isn't from a separate field like the Higgs, but from this deeper coherence.
That seems to be the idea, yes. It's integrated into the hypergravity concept. And the recursive nature of the manifold, the fractal aspect, that also helps explain the hierarchy of particle generations.
Like why we have electrons, muons, and tapas.
Exactly. Why different families of particles. Lilien suggests the first generation has the highest resonance coherence, the most stable vibration. Subsequent generations have lower coherence states, leading to greater fractal asymmetry, making them less stable.
That's neat. Okay, what about forces?
Right, the emergence of forces. Here, forces are described as manifestations of coherence fields. The manifold actually attempts to unify all the fundamental forces we know: electromagnetic, strong, weak, and gravity.
Unification, the holy grail of physics.
Indeed. They're presented not as separate entities, but as different modes or expressions of this underlying hypergravity resonance.
So electromagnetism and gravity are just different facets of the same thing.
In this framework, yes, gauge fields, which mathematically describe these fundamental interactions, they emerge from the relational dynamics encoded in these dimensional layers. Lilien specifically mentions, for example, electromagnetism as a high coherence resonance of photons, and gravity as a direct expression of hypergravity coherence.
And their different strength, like gravity being so weak.
Also explained by the fractal scaling laws, the relative strengths of the forces supposedly follow these laws, showing how their magnitudes fit into this larger recursive pattern across the dimensional layers.
Wow, okay, particles, forces. What about space-time itself, the stage for everything?
Yes, the emergence in spacetime. This is maybe the most radical part. Lilien argues that spacetime is not fundamental. It's not the bedrock.
Not fundamental. What is it then?
It emerges. It emerges from the manifold's relational and scaling dynamics. Our familiar spacetime appears as a lower dimensional projection of these higher dimensional coherence fields operating within the manifold.
A projection, like a shadow.
That's one way to think about it, yes. These dimensional layers form a hyperdimensional structure, and the fractal scaling governs the transition down to our observable 4D spacetime. Lilien suggests that at specific fractal dimensions, particularly around D4, coherent resonance produces spacetime as a stable emergent layer.
So 4D is just a stable configuration.
A stable emergent configuration, yes. Even the famous Einstein field equations, the core of general relativity, are seen in this context as just a lower dimensional projection of these deeper relational dynamics.
That takes Einstein's theory and puts it in a new context.
Exactly. And time and space themselves, they arise from distinct coherence axes within the manifold. Time is linked to fractal recursion, and resonance decay, how patterns evolve and fade. Space is linked more to the fractal scaling, how patterns are laid out.
Okay, let me try to sum this up. What this all means for us. Our familiar four-dimensional reality where we live and experience space and time moving forward. That's just one stable emergent layer, the visible part of a much deeper fractal multi-layered system. And it's all driven by resonance and coherence within this hyperfractal manifold.
You've got it. That's the essence. It's a significant shift in perspective.
Huge. As if that wasn't already enough to wrap our heads around, the concept of time itself gets a profound reimagining in this framework. Lilien introduces something called multivector time. Now, that sounds really surprising. Can you expand on that?
This is a particularly fascinating detail, I agree. And maybe one of the most conceptually challenging parts of the whole thing.
Multivector time. More than one time.
Essentially, yes. The framework suggests not just one, but 5 distinct temporal dimensions or axes, and each one corresponds to its own hyperfractal layer and one of those associated asymmetry resonance operators.
5 times. Okay, what are they?
All right, let's list them. First, there's the primary time axis, T1. This is basically our everyday linear forward-moving time. It governs causality, entropy, the standard arrow of time we perceive.
Okay, the one we know, T1.
Then there's a cyclic time axis, T2. This represents periodic oscillatory time. Think cycles, resonances, waves, repeating patterns in nature, time that loops or pulses.
Like seasons or heartbeats.
Could be manifestations of it, yes. Third is the quantum time axis, T3. This is described as a nonlinear probabilistic time relevant in the quantum world, reflecting the indeterminacy and potentiality of quantum events, time behaving less predictably.
Quantum weirdness gets its own time axis.
Okay, the fourth, the coherence time axis, T4. This one's a bit abstract. It represents the alignment and stability of all these relational dynamics. It sort of ensures temporal consistency or coherence across these different layers of time, keeps things functionally aligned.
The glue time.
Maybe, yeah, a synchronizing principle.
Yeah.
And finally, fifth, the resonance time axis, P5. This describes temporal fractal scaling. It connects incredibly small, fast quantum events to vast, slow cosmological structures through this idea of recursive resonance over time.
Linking the quantum tick to the cosmic clock.
That's the idea. So each of these multivector time axes emerges as the hyperfractal layers unfold through asymmetry resonance. The operators define their unique temporal dynamics, but coherence across these layers is key. It ensures functional consistency. And the recursive nature of the manifold means these temporal dynamics also scale fractally across dimensions, linking microtemporal phenomena to macrotemporal structures.
That's quite a departure from our usual single linear arrow of time. Does this imply, could certain events be out of sync across these different temporal axes? Or is there always a coherence that keeps everything aligned in a way we just don't fully perceive? It really makes you rethink what now even means.
It definitely challenges our intuition, doesn't it? But the coherence across layers seems crucial in the theory. While each axis has its own dynamics, they are interconnected within the manifold. The idea is this ensures overall functional consistency, which results in the single macroscopic time we experience.
So it's not things being out of sync.
Probably less about things being truly out of sync in a chaotic way, and more about our single linear perception being just a projection or maybe an average of this richer, multifaceted temporal reality operating underneath.
A projection of a deeper temporal structure, okay? What's incredibly powerful about this framework, though, is its claim to bridge abstract mathematics with observable physical reality. It's not just, elegant theory floating in space.
Absolutely. That's its biggest potential strength.
How does Lilien's work actually make this connection? And what are the real-world implications for experiments? Can we test this stuff?
This is where the theory really becomes testable, moving from philosophy or pure math into physics. The framework tries to turn what might seem like abstract concepts into dynamic, measurable principles.
Right, like coherence and resonance. How do we measure those?
Well, the claim is that what might seem like abstract mathematical measures of coherence and resonance actually manifest as observable stability and behavior in physical systems.
Your example.
Think of the incredible stability you see in quantum superpositions, in things like Bose-Einstein condensates, or just the precise, stable masses of fundamental particles. Why are they so specific? Lilien suggests these are directly linked to resonance alignment within the manifold.
So we could test that.
Potentially, yes. For example, by carefully measuring how coherence is lost decoherence in quantum computers, in qubits, we could see if the decay rates match the dynamics predicted by this framework.
Okay, testable coherence. What else?
Then there are the fractal scaling laws, those equations describing recursive evolution across dimensions. Lilien argues they manifest directly as observable fractal patterns throughout nature.
Like we mentioned before, lightning, galaxies.
Exactly. The intricate branching of lightning, the huge distribution of galaxies in the cosmic web, even the complex energy cascades you see in fluid turbulence. The claim is these aren't just coincidences, they reflect the underlying fractal scaling of the manifold.
And we can measure those fractal dimensions.
We can. We can analyze the fractal dimensions in these real-world systems and compare them directly to the predictions made by the theory's scaling laws. See if they match up.
Okay, that's concrete. What about the operators?
All right, the asymmetry, resonance, and emergence, those operators, the cosmic tuners we talked about, they govern symmetry breaking. And symmetry breaking produces directly measurable phenomena.
Like particle creation.
Yes, like particle creation and high-energy collisions. Or even perhaps the fundamental imbalance we observe between matter and antimatter in the universe. Why is there more matter? Particle accelerators, like the Large Hadron Collider at CERN, are perfect tools for this. They can study these symmetry-breaking events in detail and compare the results particles produce, their properties, to predictions derived from the resonance operator outputs those eigenvalues.
So the LHC could potentially see evidence for this.
That's the hope, or at least one testing ground. Lilien's work actually details several experimental frameworks for validation.
Such as?
Well, high-energy physics, like we just said, testing particle mass hierarchies, force strengths at the LHC, or future colliders. Also, quantum systems measuring coherence, decay, and qubits, observing resonance-driven stability in Bose-Einstein condensates. These are experiments happening now, which could be interpreted through this lens.
What about bigger scales?
Cosmological studies. Using vast galaxy surveys, like the Sloan Digital Sky Survey or Euclid, to really map the cosmic web and test its fractal scaling precisely. Or analyzing the anisotropies, the slight variations, in the cosmic microwave background radiation for potential signatures linked to these dimensional layer dynamics from the very early universe.
So looking at the universe's baby picture and its current structure.
Exactly. It even extends to natural systems, studying fractal patterns in turbulence, lightning, but also biological fractals, things like our vascular systems or neural networks in the brain. Do they follow similar scaling laws?
Fascinating. Any others?
The author even suggests exploring novel systems, things like hypothetical coherence-based energy systems, if resonance can be harnessed, or perhaps next-generation quantum gravity experiments, looking for effects predicted by the specific mathematical functions and coherence measures proposed in the theory.
Okay, so this isn't just an abstract theory sitting on a shelf or a blackboard exercise. It's being presented as a direct call to action for experimental physicists across many different fields.
That's right. It's ambitious.
It fundamentally shifts our understanding of dimensions, doesn't it? From just being passive mathematical constructs like graph paper to being active functional layers that actually do things. And it suggests the universe operates on these deep, recursive, fractal principles. It's a potential path to unifying physics.
Wow. Okay, our deep dive into the ontology of the hyperfractal manifold. It truly shows us a universe unlike almost anything we've considered before.
It's a very different picture.
From those foundational omnilectic invariants, way down deep, up through the emergence of particles, forces, even the very fabric of space-time, and that multi-layered nature of time itself. This framework offers a remarkably unified, dynamic, and importantly, testable explanation for reality.
It fundamentally suggests, doesn't it, that what we observe, our entire perceived reality, is just the surface manifestation, the result of deeper, hyperdimensional dynamics unfolding underneath.
Where everything is interconnected through these principles of coherence, resonance, and fractal scaling. And this unified perspective, if correct, could provide a really robust foundation for understanding the universe's structure and behavior across all scales, from the tiniest quantum jitters to the vast cosmic structures, and maybe even into natural and biological systems too.
Yeah, the idea that our dimensions aren't just mathematical backdrops, but are living, dynamic components actively shaping reality. It's a truly profound shift in thinking. It changes everything.
It reframes the questions we ask.
It really does. So as you go about your day, maybe just think about this. If everything, from the mass of the particles making you up to the way galaxies cluster across the universe, arises from these hidden dynamic layers of resonance and coherence, what other unseen, fractal, perhaps recursive patterns might be at play? What forces might be shaping the complex systems all around you, maybe even influencing things in your own life in ways we haven't even begun to understand?
It opens up a lot to ponder.
Definitely something to think about.